works is actually making sure that the DevOps community in Africa is actually globalized. So it's really an honor for us to have Kobus here. And Kobus will be sharing with us some things he learned from AWS, his own DevOps implementation. Please let's welcome Kobus.
Thank you. Just first to clarify, it's you didn't move because I'm important, you moved it because my wife is more important than I am. Because we've got a baby due 1 December, and there was a kid doing it next weekend would be too close, so I don't want to take a risk, so that's why I said, well, let's do it this weekend. So firstly, thank you for having me today. It's my second time in Nigeria only. I came up in August for the first time. What I want to tell you about today is some of the things that I've learned about DevOps over the years. So firstly, a little bit about me. So the first part is that I've been a software developer for about 15 years. I've done backend systems, some mobile apps. I've even worked on a game that is in Steam. And then over the course of the last 8 years, before I joined AWS, I was actually an AWS customer. So I built most of the systems that I work with that were cloud-based on AWS. And then in terms of the DevOps story, I actually started the DevOps Cape Town user group back in 2015. And when I saw that picture up earlier of having that many people at the first meetup, I was very jealous because I had 5 people at my first one, and I was one of them. So yeah, having that many, that's very, very good. And also as mentioned, just quick clarification, so I am part of the DevOps Cape Town group, not the South African one, so we do it per city. There's also a group looking to do a Joburg one. But what I can recommend is you get that DevOps days going, because it really is awesome, and also connects you to the international community very, very quickly. So, what are we going to be talking about today? So the first thing is we're going to talk about what I've learned, and we're going to do a couple of just clarifications, what I mean when I say things. So the first thing is, when I say what I have learned, what I actually mean is what I broke and how I fixed it. Because that is what experience is. So when you start thinking about what an expert is, an expert is someone who actually knows how to break things and all the different ways you can break it. And the reason this is important is that if somebody shows you the correct way to do something, but you don't know why, you're just going to copy and paste and hope it stays the same. And then one day, when the situation changes, you aren't going to be able to understand how to adapt to that change and deal with it. But if you've broken the database 50 times already, I have, you will know which of those things you shouldn't try again because you know it will not work. You might not know the correct answer, but you might have 50 or 60 or 100 incorrect answers in terms of how not to do it. So another definition quickly that I want to touch on is DevOps engineer, which came out in some of the talks today in the sense that it shouldn't be a title. And I agree with that. I do, however, just want to wrap it up nicely that yes, I have been called a DevOps engineer. I've even been a team lead of a DevOps team. So yes, while I do say that, listen, the world is moving and you shouldn't use it as a title, there is either a good reason you might want to, because DevOps, the word, is exactly like salt. And what does it do? It actually makes things look better and more appetizing if you rub it on it. So picture a steak without salt, and picture one with salt. Engineer, DevOps engineer, all of a sudden the recruiters start going like, I want to place that person. So there's a reason why it's happening, and while we can fight against it, just understand that it isn't necessarily such a good thing because there's actually a lot of components to DevOps, and it's not just the title and the tooling. And just quickly, one last fun tweet around that, is that also around tooling. Is that there's no one specific DevOps tool. There are multiple bits of tools that you can string together to actually make up, let's say, a DevOps tool chain of some kind. But it's not like, oh, this one tool is my DevOps and putting this in will actually solve it. So the first thing that I want you to take away from today's talk is that try to be the person that actually helps companies change and understand that DevOps is a whole host of different things. It's not just tooling, it's not just a title. There are a couple of things to it. And now we get to the point where we start looking at what exactly is DevOps. And I'm going to steal a definition from Dan Marr, who did a talk in 2016 at the very first DevOps Days Cape Town. And he used this acronym known for DevOps. What it is which is CAMS. When we start breaking it down, the first portion is culture. And when we start thinking about culture, it's not just, cheese. It's actually more about how your company operates and how it does certain things. So, fun story here is that when I first started my career many years ago, on my second day I was given a task which was to go look for users in the database that was abusing a sign-up system. So it was a very clear pattern that used a specific email domain and also the usernames of a specific pattern like couple letters, couple of digits, and all that. So I went off, spent about half a day writing this interesting SQL query. It was about this long with nice thick where clause. Then took it to my senior engineer who was helping with this, and we ran this leg and had a look and said, okay, cool, this looks well. You missed one or two more things, but once you're ready, go for it. So I went off, fixed the one or two last more things, and when I ran this leg, it brought back about 10,000 records. And at that point in time, we had about 500,000 users on the database. So I'm like, I'm very confident, it's been reviewed, we're going to do this, let me go to the production database, and I ran it. And it's like, I hit run, and it's like very quick, where the select was a little bit slower due to the wait rules. And I immediately go like, okay, it's interesting, and then I look down at the result bar, and it says 500 and something thousand rows affected. Yeah, you have that feeling where you go like, oh crap, what did I just do? So, what did I do? Well, I was very diligent. I took the query across, and then to make sure that I didn't run anything incorrectly, I highlighted the query part that I want to run. The part that I highlighted was update, table, set, lock equal 1. No wait rules. So, moral of the story is that A, don't run things on production, but B, the other part that you should know about there is that it's blameless. So you don't want to be in a situation where you get blamed for it. So I quickly learned how to look at logs, how to fix things, and actually how to look at post old database backups. And luckily, I didn't have to deal with this situation. And in this situation, just quick show of hands in the room. Who has tested their backups at work in the last week? Let me rephrase. Who knows if the backups at work actually work? Anyone? No? Can anybody actually confirm if the backups aren't empty? Okay, what are you going to do tomorrow? Or Monday, rather? No one? Go check your backups. So once again, one of those things to take away from the session, not a point, but it is go test your backups. Because a backup is like shredding this cat where they put the cat in the box with the poison that can possibly kill it or not kill it. Until you've tested your backups by restoring them, you don't know if your backups are going to work. So please, even if there's nothing else to learn today, just go do that one thing. It will save you a lot of heartache. So I spoke about the blameless culture. So after I did all of that crap and broke the database for production, locking everybody out, the next step was quickly chatting to the senior engineer that helped me, and he said, okay, cool, well, let's fix this, so unlock everybody. So now we will have some bad actors in the system. But then we went through systematic and said, well, cool, let's go look at log entries where we saw someone who was locked in, let's say, the last week or so, and go lock those entries again. Then we took the actual log files of the last 2 or 3 months and wrote a little parser that actually went through, because when we did lock, luckily we logged the event of locking someone with the user ID. And then used that and extracted that user ID into a query to then go and re-lock people that we had locked in the past. So it was a very dramatic experience, but I wasn't blamed for it, because the question came up, what is a new person who's never done any kind of software dev before 2 days ago doing on the production database? So another takeaway, let's give people database access on day 2, especially if they are new or old person. So, next part of that's important is, in terms of your culture and what you want to start getting at going to work, is you want to be the cat in their house that actually teaches people about DevOps practices. So, what you want to do is look at what people know and what they don't know, and then always assume that they want to learn and you can help them learn. Just assume that they don't know something and they're stupid. Because if you think about learning is actually a fun act. The best example of this is, who here has not seen what happens if you take a Mentos mint and pop and throw it inside a Coke bottle? Have you all seen it? So, for those that haven't seen it, I'm going to make you day. What it does is, it actually gets all the gas to go out of the Coke immediately and creates this big splash and big mess. So it's so much fun. So if you haven't done it before, just go do it. And that's how learning should be. It's a lot of fun. Have fun with it and help others with it. So you want to get a learning culture going at work where you learn the whole time and try and improve. And the reason this is also important is that unlike other professions, like let's say building a bridge, where you know exactly how it works, you know the physics behind it, you know what all the parameters are, what all the materials are, you can actually study and learn everything, and once you know everything, you then go and apply everything. We can't do that with software. The field is moving too fast. There will never be a point where you can say, I know everything. If you know everything, you're way too young, and it just might be like a bit of Dunning-Kruger sitting. There's no way you can know everything about computers and software development in general. It's just too complex. So understand that you're going to be constantly learning. So don't be like some people who, I can't remember who coined the phrase, but it is mentally retiring at 30. Which means that by the time you hit 30, you think you know everything you need to know for life, and you don't need to learn anymore. Constantly be learning and actually figuring out new things and helping others to learn that as well. So the big takeaway here is that you need to learn from your mistakes. Because in general, you don't want to say, well, let's figure out how to handle a production outage. deleting the database. That's not a good way to learn. But let's say hypothetically you had this employee called Purvis and he did do things to your database. Go learn from that opportunity what is there. Give me a second, I think I'm out of... Something's happening. I think I stepped on the cable. Okay, wait. Give me a second, it's not back on the wrong. Yeah. Dun. Windows. Let's just try this again. No, it's not happy. I think there's something wrong with this. Yeah, but it's not the right resolution. Oh, let's see quickly. Current slide. Cool. Okay, that's right. Right, then we just learn from a production failure. Just continue going, that's anything. Cool. Okay. So that's the culture aspect of the chaos portion. The next one, and this is probably what most people in the room who want to learn about DevOps are interested in, and that is the automation aspect. And when you start thinking about automation, a lot of people will go, yay, let's automate every single thing we have. Once again, guess who's done that? We spent a week or two to automate something that takes about 5 minutes to do by hand, and you only do it twice a year. Yes. Learn from me. So there's a very nice, in general, it's a fun site to look at, XKCD. So just quickly, all the slide deck as is will be published both by the developers of the DevOps NG group as well as on my SlideShare.net account, so you will be able to get everything with links to everything in there. But what this slide shows is that you can actually look at the different axes here. So at the top, you ask how often do you do a task, and then also how much time do you save on the task. So let's say you've got a task that you do 50 times a day, and it takes 5 minutes. What this grid tells you is that you should be able to spend 9 months on that task before you've spent more time automating it than you would have spent on the task itself in 5 years. So just as a quick look up, that example that I just had is, let's say there is something that takes 5 minutes and you do it every year. I should have spent 25 minutes on it and not 2 weeks. So use this. This is just an easy lookup mechanism to get a feel for how much time should you be spending on automating different tasks. And now speaking about automating tasks, I'm sure some of you have dealt with a runbook that looks like this when you are trying to deploy something, where it becomes a little bit crazy. It's pages and pages of steps that you have to follow. So this is too complex. It takes too much time. It's really hard to actually understand what's going on. And especially, let's say you were lucky enough to have this runbook, because this runbook was written by someone else who now left the company. Well, it's great having it. Who's going to want to dig into this and figure out that step 322 needs to be replaced with 2 extra steps and then up everything? Anyone? Nope, I wouldn't either, because that'll be so much manual, so much hard labor. So, quick takeaway here is that you want to start applying the guess principle. And no, please don't do like we did earlier and turn to each other right now. This is not what we're talking about. We are talking about keep it simple, stupid. In the sense that you want to keep things as simple as possible. The reason is the more complex it is, the harder it is to understand, the harder it is to explain to someone else to understand, and also for them to learn what is going on. So, quick show of hands. Who here works at a startup? A couple of startups. Okay. So, if you were running your startup and you decided to go, let's say, full-on microservice route, you want to deploy Kubernetes with the service mesh, canary deployments, centralized logging, and all those nice things that we keep on hearing. But this is now a new startup. The same people who here would actually pay an engineer to go set up that complex infrastructure setup before you've actually figured out if your product works. Anyone? No. The reason is that you're now investing in complex infrastructure and you're overcomplicating things for stuff that you don't need yet. You don't need that complexity on day one. So I always put this slide in pretty much every single presentation that I do, which is monoliths are okay, especially if you're a new startup and you want to try and validate your product. But also, let's say you're in a company where you're building a new system that needs to do some things, and you're not certain whether or not you're going to keep that system. Unless you've already got the capability to run a complex microservice architecture, don't go spend engineering time on something that you're not sure will be worth optimizing. Because remember, not all systems need to scale, so you might be fine to build a small back-off system as a as a monolith, and then just deploy that 2 copies of it. Because that'll save you time and you can actually get to the business problems, which makes your business money. Because once again, always think about what your role at a company is. So on that, how many people think that if your title is engineer, software developer, that your responsibility is to write code? I used to. It's obviously a trick question because I see a couple of you going like, I know this is going to be wrong, but let's see what happens. No, your role as an engineer is actually to solve business problems. That is what drives the business forward. Happy business owner, happy business that makes money is the one where you can then go and spend time on actually building and playing with those features that you want with that make the software more stable and actually help it scale up. So always keep that in mind. Because what you don't want to do is you don't want to be this person. So the joke here is that, yes, you have to look very closely to see the blog. Let me just highlight it for you quickly, just for those that haven't seen it. So you see there, and the rest of the truck, the euphemism here is that's the whole Kubernetes deployment, which is very so another little bit of tip here is that what I know that Kubernetes is very, very popular at the moment, and a lot of people are building on it, and it seems like it solves all your problems. Take a step back, just double check, do you want to take that level of complexity on? And also answer the question, if we were to go with this, can I explain this to a new person joining us without Kubernetes experience in a week or a month to get them productive and up and running? So just think about that when you start going, hey, it's Kubernetes and all. You don't always want to have that level of complexity. So, what you do however want to do is bring in some infrastructure as code. So now let's say you're at the point where things are a bit more complex and you do have a lot of microservices running. And a lot of the microservices have got their own build pipelines, you deploy them, you monitor them separately, and they all do their thing on their own. You definitely don't want to be creating all of that infrastructure by hand, bit by bit, and expect every single team to do that bit by bit. What you do want to do is you want to start leveraging infrastructure as code. So the big benefits and the goals of infrastructure as code is the first one is that you want to make the changes repeatable and predictable. Because once again, who here has before gone to the boss and said, hey listen, I'm going to change our database instance size from a small to a large on production and I hope it works on a Friday. Yes, no, you don't want to do that. You want to be able to say that, listen, we've done this before, it's repeatable and it is definitely going to work, it's predictable. So if you did it with, let's say, infrastructure tooling, you could have said, well, we just tested this against development and staging, and look here, it actually went through without any issue. This is what we learned from it, and this is how we know that it's going to behave the way it's supposed to. So you get that confidence of saying we know what's going to happen. The second benefit is better illustrated with a pipeline that we might be used to for code, where you've got your source sitting somewhere in a repository, you check that source out, you then build it. And then once you've built it, you hopefully test it. Testing is important. And lastly, you can then do some kind of deployment. So we're very used to doing this with code. We're used to doing pull requests where we have a teammate review it. We've got tooling that actually looks at that pull request, comments on it saying, how many lines of code are we changing, is it too complex, all of those things. So why are we doing this with our infrastructure? Sorry, taking the line here. The good news here is like infrastructure as code literally means as code. So it is the same text that you would commit as you would your normal software that you're writing. So commit it to the repo, have a branch where you make your changes, do a pull request, have your peers in your team or company review that change, and then also send it through your CI/CD pipeline. Because the tooling available nowadays allows you to take that and actually get to a point where before it applies, it'll tell you, what am I going to change in my infrastructure? Take that output, put it against the PR, because then you can say, okay, cool, these are the 10, 15 lines of code we're going to be changing, and now at the bottom we can see all of a sudden the web servers are going to go from 5 to 500. You go like, hey, whoa, hold on, why are we changing this from 5 to 500? And they're like, oh, sorry, the typo, I meant it to go from 5 to 6. I just missed out, sorry about that, and then committed a push. So that's the second goal and benefit of infrastructure as code, where you are actually able to use the same tooling that you would for your code. Your infrastructure changes also live next to your code in the same repository. So when you make changes, you can see how the system progressed. And also, once again, that example where if someone left and you lose institutional knowledge of how did we change from the initial infrastructure setup to where we are now, everything's in Git history. Just look at the Git history. You can see what happens. Also, in terms of documentation, everything's already documented because you can see exactly how your infrastructure is created, and you can get quite far with this. And then the last one that is a big benefit, and I know a lot of people, if they don't have enough automation in place, struggle with, is that your different environments all look the same. And when I say look the same, I don't mean that the config is the same, because you should be sharing credentials between dev and production. Because imagine having the same database password in dev and production, and then someone gets the dev password. Sorry. Like I said, I'm an expert in how not to do things. And then the second part is that the quantities differ. So you might have, let's say, 2 web servers in your dev account, and you might have 300 in your production account. So the quantities differ. but the way it's built up looks exactly the same. There's a web server, there's a web server. Load balancer, load balancer. Database, database. So the way the different environments look is exactly the same, because the only way you can get infrastructure into the environment is by using this automation tool that you have for your infrastructure as code and get it out. So this is the takeaway for this one, which is use that tooling as much as possible. And even with existing environments, there are ways you can slowly bring your infrastructure under control with automation. I've done it with some companies before. It tends to be a little bit easier to say, let's spin up a second environment and slowly move services across one by one from non-automated into automated, but you might not be able to do that, but it's still possible to do it either way by just adding automation to the existing services and infrastructure as well. So the next part of the automation is best illustrated by this. Who's done this? No one? Am I alone?
Yeah, I'm done.
Okay, come on. I was about to say, come on. I can't be alone on this one. So, being able to build on your machine and then it doesn't build on the CI server is a very, very bad experience. And the one thing that I can hear, and this will be the only AWS product you'll see me speak about today, and I used it before I joined AWS, is because it's so cool, is code build. So what code build is the ability to run a container to actually do your build for you. And what this means is that you can use Docker to actually build your software locally as well as run the tests locally. So you want to be able to make it easy to go build and test. Because that's simple, everybody can understand that for every project that I check out, I need to be able to run a build command and a test command, and it works. And if it's inside Docker, it also means that I don't have to worry about installing all the different tooling on all the different machines to actually deal with that. Second part is that I can also go create those build containers that have specific tooling in that I need. So let's say I've got a framework that I need for my Node.js application. I can install that inside the build container and know that when I execute that test command, that framework is available because the container will have it in there. So use containers and specifically use AWS Code Build because, like I said, it is a really easy way to get builds running. And the second benefit is that it's per second billing. So as long as the container is running to run your build, that's what you're paying for. And then when it's done, it's done. You don't pay for just having the ability to build. You literally just pay for when you want to build. So if you think about some of the other products available out there, some of them have like a base monthly fee just to be able to build. Some of them limit you in terms of how many workers you need, and if you want more parallel builds, you need to pay more for those extra builds. So this is one of the reasons why every time I tried a new CI/CD tool, I ended up coming back to AWS Code Build because it's simple, it's easy, and I can parallelize pretty much as I want to because there's no penalty in running multiple builds in parallel. And just quickly on that note, simplifying things. This is not to teach you how to use AWS Code Build. This is just to show you how to simplify things. And what I've learned over the years is to keep things, once again, as simple as possible. And what is simpler than telling a person that any project you go into, you go make build, make test, and when you're on the CI server, you can go make package. And that'll actually do those steps. You can do them locally as well. Locally, you literally go get clone, make build, make test, and you can run those tests and those builds. I don't need to know anything about what's happening behind the hood. I can obviously now go dig in because I can see everything because everything is coded in there to see what's going on. But this inside of, especially larger organizations, make it super simple. Because this combined with Docker means that you don't need to even know what language you're dealing with. You just know this is how you build things. And once again, now when you want to start playing with different CI tools, because I went I tend to always come back to Jenkins. I know a lot of people say, oh no, Jenkins is old and it's not cool anymore, but it actually does most of the things you want to do. So I kept coming back to Jenkins after trying with various other third parties. And if you're doing these different tests, imagine how hard it is if you have to keep adjusting your scripts that do your build, your testing, and your packaging for every different tool that you use. Doing it this way means that now in my Jenkins file, all I have is make test, or make build, test, and package. Similarly, now I want to move to the new thing that just came out and was ready to hack and use, because I want to be cool. Then you can easily just do it, copy across those commands, run it against it, and go play with it a little bit. So there's a very interesting quote around this, which is this one. And what this boils down to is that something that's simple, a lot of people say, oh well, that's not too interesting, but simple things grow to be complex over time. And if you can take a complex thing and make it simple again, while keeping all the attributes that in terms of running it, so think of very complex microservice architecture, and you can get to that point where it's easy to interact with and simple and people can understand you, there's a lot of value in that. So, key takeaway again for this one is try and keep your builds simple and your tests simple and make it easy for people to do that. The additional benefit is that how many people have worked with teammates who would write code do not build or test locally and then just commit and push and say, oh no, the CISO will figure it out, and then it breaks the build to someone. Oh, sorry, I was that person. So think about that. Make it easy to do that. They call it the check-in dance. Like, click. Sorry, I can't dance. Where you can do those easily locally. So you can quickly go make, build, make, test, enter, wait for it to finish, and then you commit and push. That makes it a lot simpler to do the right thing. If the right thing is simple, then people will actually want to do it. So that covers the automation part of this one. So now we start getting into the next layer, which is M for measure. And this is where I personally had a lot of struggle initially. Because when you start thinking about measuring things and making improvements, this is what I typically tell people. Hey, I made it faster. How much faster? Hey, I made it faster. You go like, okay, but that's cool and all, but it doesn't really validate whatever it is that you did. So what you want to do when you start applying DevOps practices, measure everything, especially when you want to make an improvement. The second reason for this is that, there's a great book I'm going to show you a bit later, is that when you look at a system as a whole, you have to be working on where the bottleneck is. Because if you're not improving the bottleneck, you're not improving anything. And a nice way to think of it, stolen from the one book, is that let's say a car manufacturing plant. You've got people building the individual components like the doors and the chassis and engines and things, and these parts go to a central point. And then after that point, you've got the assembly, where they start assembling the cars. Now, parts start heaping up over here, because the cars can only be built at a certain pace. They can leave as soon as they're done, because that conveyor belt works fast. Now you spend time, instead of figuring out how to assemble the cars quicker, you figure out how to make the doors quicker. All that you've done is you've now made the doors quicker, and this pile of doors is just going to increase. It's not going to make more cars go out on the other side. So think about where you're spending your automation and your effort, automation energy effort, in terms of making this, the system run better and making in general removing bottlenecks, whether it's with a process or with some kind of build service or anything like that. You need to really figure out where is the best place to actually spend that energy. So from my personal experience here is where I did figure out that, hey, this is something worthwhile to do, is I dealt with a very large database migration. And when we first wrote our scripts, it took us about, I think it was 24 hours, or just over 24 hours to do one migration. Now, because of the changes in migration, it required us replication changes and a whole bunch of other things, so the system had to be down. Now you can imagine the response when I said, and this is a system that makes money per minute and hour that it's up, because people transact on it, that the feeling, or the boss's reaction, I said, well, we're going to have to switch this off for a whole day. Hell no was the answer. So what I did there is then I said, okay, cool, so we know what it's going to take now, we're going to do it as it is. Spent a lot of time working on getting it faster and faster and faster. And it got to a point where I got down to 3 hours. And then when I went to the boss and said, listen, I've now spent a week or two on this, I've learned the following things, I've gotten it down to 3 hours from 24. I can now measure how much better I've made it. That was a much easier conversation to have, because then he went like, oh, okay, cool, so I can see you did stuff, you're telling me how much better it is, let's see if we can work around this, or let's see if it's worthwhile spending more time to get it maybe down to 1 hour. The answer at that point was no, 3 hours we could deal with, because we could do it early in the morning, like I think it was between 5 and 8 a.m. So yes, it's not ideal because the system is down, but there weren't that many people in the system, versus an entire day where we lose a whole day's worth of revenue. So think about that when you want to make any kind of change. Because it's much easier to argue using data points. Because remember, data points don't have feelings. They're just data. To make your argument, instead of saying like, I hope this will make it better, or I feel this will make it faster. If you come to me with that, I'll go like, show me the numbers. Because I also have a feeling. My feeling is you're not going to be fast. So you see, feelings are super subjective. You shouldn't use them to make these kind of decisions. Always try and back your things with data points by measuring everything. So, sorry, I was supposed to click about that. So, it does make it a lot easier to actually convince people when you use data points and for your arguments. And then those books that I mentioned, the first one is the Phoenix Project, which is literally reads like a story about a manager who then has to help a company start adopting more modern practices and turning it around and not blaming people and dealing with different egos and things. Very, very good read. You can probably read it in like a weekend or so. It'll give you an idea of hey, what's possible in terms of organizational transformation and also the DevOps journey of some companies have. And the second one, and this one I try and reread every single year since it's come out. So the previous stat we had, I think, which showed the 55% increase in the 22% in terms of that came from the DORA report, which is the DevOps report, the state of the DevOps report. I can't remember how they get to DORA. That's the association that did it. So Nicole Forsgren is one of the founders of that, and she actually started this whole State of the DevOps report every year. And this book goes through, firstly, what the questions are, why they pick the questions, and how they structure the questions to get that information. So it tells you that we asked a question that says, please rate the following between 1 and 7. And then once rated, they took all of that data and then did statistical analysis on it and said that, listen, we can see that companies that do the following things out of this long list are like clustered over here. They are like the medium performers. But then there's a massive gap, and over here we see another clustering of the different questions that are answered in a certain way, where these are the high performers. Now, what makes a difference between them? And it's very, very insightful, and every time I read the book, there's something that I take away from it again. So one of the best takeaways that I had was that if your system has got errors in production, that is not a good metric just to say how many errors do we have in production. Because let's say there's something that your web server for some reason goes down 50 times a day. That definitely sounds very, very crap and like a very bad user experience. But let's say it takes half a millisecond to recover from that, and you've only got, let's say, 2 or 3 requests that are dropped out of millions that you're using. Your users probably won't notice. There will be 1 or 2 in the day that notice it, but they won't notice it. Compare that to 1 fault a day that takes your site down for 5 minutes. Which one of the two is worse? So, if you think about it, that's just one of the takeaways. So what you need to measure is mean time to recovery, not just number of errors per day. So like I said, there are a lot of good things in this book, so I can highly, highly recommend that you go read this book. So now we've covered the measuring portion. We now need to get onto the last one. Let me just check how we do time. We are out of time almost, so I'll rush. Is the sharing aspect. And remember, sharing is caring. And I was actually very, very happy when this whole day opened up with the explanation of what the DevOps Nigeria group is doing inside inside Nigeria with all the different programs and things. Because one of the big things that I want you all to take away is this one. And this is that every single person that has solved a problem probably has a talk in them. So go think about what you solved in the last while and go share it. Because that's how you help the community grow. Because being able to deploy containers at scale or set up a multi-stage Docker build isn't the thing that makes your company do better than the company that can't do it. So help the people around you learn more and learn from each other. And try and do these talks because there's always a need for more and more speakers. And speaking on having more and more speakers, the other part that's super important is diversity. In terms of opinions and people inside the organizations. The reason is that different people have different ways of doing things. There was a great talk by, once again, Dan Murray this year at DevOps Days, where he compared, hopefully you can't read that because it'll spoil the punchline. He did a talk on how the mixed martial arts is the same as DevOps. And the example he used is that if you are going into a fight and you can only do a single type of punch, you're probably not going to win the fight because the other person is going to be able to do lots of different punches and then beat you that way. People seem to understand this. But then when you take it into the software world, if you've got lots of different ways of doing it, people are like, no, we don't need that, we just need to know one way of doing it. And the way you reference it is that if you think of fighting as being able to throw a punch, it's the same as defining software in a fun one. And now, just before I give you that little fun definition, I need your help with this. So I want to send him a couple of tweets, so if you can get your phones ready to take a photo, and also punch out, oh wow, no participation. Anyone can help me with this? Okay, we got 1 or 2. His handle is unfortunately very hard to spell, that one. Frost. Easy to pronounce, hard to spell. But basically what he said is, if you think that boxing and fighting is similar to just a person throwing punches, this is what you could call software development. And if you think about software development, it definitely is a lot more complex than just this. So think about how you can get different people's opinions about different things into your workplace and actually think about the problems differently. This doesn't mean that, hey, let's take every single opinion and just apply it. It does have to have at least some backing and some data points preferably to convince you to actually do things. So in terms of, in closing this talk off today, one thing that I do want to let you ask you if you are interested in AWS related things is there is this AWS community Slack group that we have. And if you want to join it, it's completely free, because the thing that I'm trying to do is there's so many different people that know how to use AWS and want to talk about it and show others how to do it, but there's no easy place to share it. So I'm trying to get as many people to this site as possible and actually have them then discuss what they're doing there, how they're doing it, solving their problems, what meetups they're doing, what talks they're doing. Basically just share anything they want. Because at the end of the day, this is the goal that I'm aiming for, is I want everybody to be this happy when they start playing with DevOps, especially AWS tools. Yes. So with that, thank you. Yes, I have two questions. Cool, the first one. There was a question about resiliency and building systems that can handle failures. So, highly recommend this person to follow on Twitter. He is on my teammate, so I'm a little bit biased, but he's writing some excellent articles on how to build resilient systems, fault tolerant systems, and all the different ways you can break the system and actually recover from it. And then we did have one question that said, hey, what happens if a whole AZ disappears? And the good news there is I actually have slides for this. So let's say you've got your multi-availability zone architecture with your web servers spread across all three, and you've got a database cluster set up so it's got one node and one AZ and a second node and another AZ. And what we can see over here just is that's the primary node at the moment where all reads and writes happen. And then all of a sudden, something happens, like lightning strikes the data center. This happened to me in 2011. This is where I learned that this is important. Once again, tell me how I broke it. The whole AZ goes down and you lose both the web server and the database in that one. What will happen in that instance is that your load balancer is smart enough to figure out that, hey, I should stop sending traffic to that instance because it's not healthy. The next step that's fixing is the managed database system will then detect that, hey, that main node is not available anymore, and start redirecting traffic away from it. So your system degrades, but it doesn't break. So this is where the important part comes in when you think of disaster recovery versus resilient systems. So while, yes, it's nice to say you've got a full hot system that's running elsewhere that you can just fail over to, wouldn't it be better if your system can actually handle the failure of individual nodes? And for those that are brave, that want to run on this level, Netflix actually has a whole suite of tools called the Simian Arm. It starts off with Chaos Monkey, which you give it AWS credentials and a bit of configs, and then it'll randomly go and say, instance, terminate. So it tests your infrastructure. So it literally goes in and terminates things. You can obviously configure it not to terminate everything. Then one up from that you get Chaos Gorilla, which does exactly this, which is everything in a specific availability zone, delete. Then they've got the big one, Chaos Com. You can see where this is going. Where they actually delete an entire region to test if the systems can handle it and do the failover. Yes, no, the whole region. Yeah. Because they spend a lot of effort into chaos engineering and making the systems resilient. And they actually do failovers between America and Europe, just to make sure that they can handle the traffic. So yes, it's not a great user experience because things are kind of slower because of the latency, but things are still up. And I would prefer to wait 5 or 10 seconds to load my Netflix movie when it normally took 1 second to having no Netflix. So yes, think about what's better for your customer. Degraded is better than completely broken. And then just quickly on that, another easy way to get things with auto-scaling groups. I know there was someone who said, I think it was Aware who said it took his job away with 1,500 instances when it just brought those up. But let's say you want to just easily make your service a little bit more resilient and keep it up and running. Deploy 2 copies of it with auto-scaling group. Because what will happen is that if one of those instances die, the auto-scaling group will see, oh, well, it's down, and also the load balancer will see, don't send traffic to it anymore. And then the auto-scaling group will bring up a new copy of it. And then once that new copy is live, guess what? The load balancer says, yay, you're happy, we can send some traffic to you again. So there are some easy ways you can actually get a bit of more resiliency into your systems. But like I said, if you really want more detail on this, go to Adrian Horn's webpage. He's got a whole blog series on this. He actually builds tools for Python and a couple of other, and like he's got an AWS, I don't remember what it was exactly, but it's a mechanism to actually inject like network failure into your running EC2 instances. So if you're interested in this, definitely go read up on his stuff and go look at some of his videos. So, who else has a question? Someone at the back there. Let's start here while they run to the back. Yeah.
So just one more, then yeah.
Thank you for the talk. So that's really very interesting. Since we are part of the part that really talks about DevOps and learning, that's really I'm asking this one. Actually, a very basic question. So I'm a software engineer. So when I'm in this meetup, sometimes you hear some things you're like, okay, that's you hear other things you don't know. So my question is there a learning path for DevOps? Is it like when you finish the complete AWS course, maybe on your site, you're not a DevOps engineer, or how do you transition to it? Because literally you don't see any junior DevOps role anyways, like those guys are born badass and everything. So I want to know, how do you become a DevOps engineer?
Luckily, that's a very easy answer. Break things. The reason you don't have a junior DevOps engineer is you typically had to go through the cycle of breaking things and learning how to fix them. And a lot of people use junior and like mid and senior as a time increment. And if you're junior, it means that you haven't broken anything, so you don't know how to fix it. So like you're a DevOps, you don't need to fix it. But I mean, more seriously, there's a lot of training you can do. there's not, like I said, DevOps engineer isn't a title. It isn't a role. It's more like all the things that we spoke about. So there's no easy way of saying that if you go through this, you'll be able to fix all the problems, because there's so many different types of problems. So it's all about learning how to learn again in terms of how to handle things. And the thing that, for example, that I got very good at is I can have a new problem that I've not seen before. But because I've had so many different problems, I can kind of feel out what the shape of this is. Is this a networking problem? Is this maybe a slow database problem? Or is this something else? And that's where you start getting better and better in terms of being a better DevOps engineer. It's like, oh, sorry, slow there. Platform engineer. Is that you're able to spot those a lot easier. And just quickly, so what I just said now, platform engineer is what you should be pushing for in terms of titles. Because if you think about groups of engineers, expecting every software developer to be able to understand their language that they're using, the database that they're using, and then also all the infrastructure that they're using, including the build automation and all of that, and even understanding all the details of, let's say, Kubernetes. That's quite a lot to understand. That's not going to happen often. So what you should do is rather see if you can get like a small platform team going. And what they do is they build, for example, the automation that allows you to spin up the CI/CD pipeline for the different languages and make it easy to use. And then, as what was in a previous talk, is you do not force people to use them. What you say is, this is an easy way that you can, for example, deploy your Java apps inside containers. And if you use this, and you want additional features, come talk to us, because we can then help you add those features and actually show you how this works. And if it breaks, we'll come help you look at it. But if you don't want to use this, that is fine. Just understand that we're not going to come and sort your problem out. Because the problem is, what often happens when you start having the DevOps engineer title is that they view you basically as a sysadmin. As in, I write the code and I throw it over the wall, and someone else is going to sort out the deployment, and the running, and the fixing of it when it does break. And we're just back in the old world, except everybody now is no longer named right, because now it's no longer ops engineer, it's now DevOps engineer. Cool. There's one
One more question.